Question 5, AQA Level Chemistry, June 2019, Paper 1. Can't do question 4 because it contains transition, metal complexes and shapes. I haven't gone through that yet. So question 5. Group 7 compounds, give an equation for this. So it's just going to be solid sodium chloride, NaCl, plus H2SO4, arrow, NaHSO4 plus HCl. NaCl plus H2SO4 arrow NaHSO4 plus HCl. And the role of sulfuric acid in this reaction is a proton donor. Fumes of sulfur dioxide are formed when sodium bromide, NaBr, reacts with concentrated sulfuric acid plus H2SO4. And we know we form. First thing we are gonna form we're gonna form SO2 because as fumes of sulfur dioxide are formed. We're also gonna form Na2SO4. So NaBr plus H2SO4, Na2SO4 plus SO2 plus Br2. Plus 2H2O. I'm gonna have a 2 here and a 2 here. 2 NaBr plus 2H2SO4 arrow Na2SO4 plus SO2 plus Br2 plus 2H2O. Give one other observation. Well, because we're forming so it's gonna be brown gas. And then state the role of sulfuric acid. Well, it's going to be an oxidizing agent. So 2Na plus 2H2SO4 arrow Na2SO4 plus SO2 plus Br2 plus 2H2O. Brown gas formed is an observation oxidizing agent. Chlorine reacts with hot aqueous sodium hydroxide as shown in the equation. Give the oxidation state of chlorine in this and in this. So in here, well, let's do the second one because that's a whole lot easier. But Na is going to be minus 1. No, Na is going to be plus 1 because we know Na has got an oxidation state of plus 1. So therefore Cl must be minus 1 to get an overall charge of 0. So minus 1. Now for the top one. Well, chlorine is going to have an oxidation state of plus 1. It's going to be minus 6 plus 1 minus 5. Therefore, no, completely misread the question. completely misread the question. That's why it was so difficult. Na is obviously going to be positive. Oxygen is going to be -2. There's 3 of them. It's going to be -6. -6 plus 1 is -5. Therefore, the chlorine must be equal to 5 to get an overall charge of 0. So it's going to be +5. Just completely misread the question. And that is for 1 mark. And then we've got 5.4. State in terms of redox what happens to chlorine in the reaction, question 5.3. Well, you can either like look at it from here, but you should have studied this equation before, and you should know it's a disproportionation reaction. But in terms of redox, well, chlorine is both and then question 5.5, solution Y contains 2 different negative ions. Add silver nitrate solution, add dilute nitric acid, and therefore you get excessive concentrated, and then add excessive concentrated ammonia solution. Here's the observations. Give the formulas DEF. A cream precipitate containing compound D and compound E. It's going to be AG BR. Formula of E is going to be Ag2CO3 and formula of F is going to be CO2. It's got a colourless solution containing complex ion G. It's going to be CO2. AgBr, Ag2CO3, CO2. Ionic equation to form E, Ag2CO3. That's a really nice question. Well, we've got Ag2CO3. To form it, we're going to have Ag plus 2 of them plus CO3 2 minus carbonate ion. The reason we have a 2 here is because we've got 2 here. Go balance it out and we form that. Equations show conversion of D into G. So here into G, it's going to be AgBr plus ammonia to form Ag. We're going to replace Br, NH3 and a 2 here, positive charge plus Br minus. That's why we have 2 here, because we've got 2 here. That's the end of question 5.